Well, hello, and welcome to ArcArc. That's right, big A and little a for arc. So, let's jump into it. We've already done inverse, but we have not discussed all of the ways it can be presented to you. Up until this point, we have just seen a trig function to -1, which means inverse, of an angle. Now you'll also see it as arc trig function with the uppercase A, okay? That's going to be our principal values. We also could talk about if we want all values, right? Right now we've just been talking about principal, but we definitely could ask you, like, what are all the values? We've only talked about that principal one, though, so far, so today we're going to talk about all values, and I'm not going to get through all the notes, which is fine. We're just going to do a little head start in this video. So first, let's talk about all values. So let's look at this. This is coming up a little bit later on, too, so understanding it a little bit now will help you later on, because we're going to talk about this later on anyway. So remember, we did the unit circle. We know that all our coordinates, and I mean you could pop some coordinates in here too if you wanted to. All our coordinates here are cosine, comma, sine, right? And I'm going to be focusing on a sine graph real quick. So I only want these sine values. And this is what? Root 2 over 2, root 2 over 2. I mean, we can leave that off for now. Sine value, sine value, sine value. So what we're going to do later, I'm just introing it right now, is we're going to graph sine. And we graph it by looking at these unit circle points. So at 0 degrees, we are at 0. So at 0 degrees, we are at 0. At 90 degrees, we are at 1. So at 90 degrees, we are at 1. At 180 degrees, we are at 0. So if this was 180, we would be at 0. And down here, for at 270, we'd be at -1. 270, and then I could keep going, right? So 360 would be here, add another 90, add another 90, add another 90, and you get what's down here, okay? Because it goes in both directions. It goes in both directions forever. So let's look at that down there. So do you see it? This is what we graphed, but understand it can go in both directions forever. Well, how does it do that, right? Like, we go around the circle, and then we go around the circle and plot the points again, and go around the circle and plot the points again, or go backwards and plot the points, right? So another 360, or back a 360, back a 360. So the multiple cycles are generating by adding or subtracting 360 degrees, or if we use radians, 2 pi. Okay? So if we just keep going and going, we'll just keep going and going with the wave. All right, so what if I asked you for all the values of inverse sine of 1/2? Now it's going to be asked like this. Notice that there's a little a. Let's talk about it. So all the values for inverse sine of 1/2. So first thing, let's talk about sine. Where is sine positive? So if we think about this, sine's positive here and sine is positive here. And those two values are where sine is positive, but then remember, I could just keep going around and around. Like, let's go back to this. Like, what if I asked you, when is sine 1? Right? You'd say it's sine at 1 at 90. But then what if I do 360 plus another 90? Sine is still 1. What if I add another 360 to that? Sine is still 1. So it goes on and on forever to infinity, right? So there's a way we're going to write that. Okay, well, let's talk about our two different quadrants. So first thing, in quadrant 1, sine is 1/2, so let's think real quick. When is sine 1/2? And I'm going to go ahead and we'll write it right now in degrees, and we'll also talk about radians too. We might, oh no, it says we'll stick to degrees, so we'll stick to degrees for now. So sine is 1/2 at pi, what am I doing? I'm going right to radians, and I promised you I'd do degrees. At 30 degrees, all right? So sine is 1/2 at 30 degrees. Well, true, but it also happens again if I add 360 to this. So like at 390 degrees, right? Sine is still 1/2. So it goes on and on and on and on and on. So we write it like this. So let's discuss this. So it's 30 degrees plus 360 times the number of rotations forward or backward. What does that mean? So like if k is 1 rotation forward, it'd be a +1. So 390 degrees, right? Or k could be -1. That's 1 rotation backwards. So if I went here, it would be -330 degrees. Sine is still 1/2 at -330. So this stands for how many rotations forward or backward, and we're going around the circle. Okay? So that's one of all of the answers. That sounded weird. So that's one of them. We also have to worry about quadrant 2, which I have starred over there. So again, it's 30 degrees here in quadrant 2, but how many degrees is the actual angle? And the actual angle there is 150. So we have 150 degrees plus, you could keep rotating backward and forward infinitely. So these two together, little heart for you, those two together are the answers. So those are all the values forever and ever to infinity where sine is 1/2. That's all of the values. Okay, we've only done principal. This is all. Okay, so there's that. Now, what if we have capital A? Notice it is a capital A. Okay, that means principal. So this means principal value. Okay, so if it's capital A, we're going to do principal. Well, we've done principal already. This would be when is inverse sine 1/2. So remember with inverse sine, we can't go here. Inverse sine is positive here, and we already said it is 30 degrees there. So if I calculate that angle, 30 degrees is my answer. Okay, so look at the difference between the two, little a and big A. All right. Yeah, that's it. It's the only difference. So let's go on down here. Let's try this with a calc. Okay, a little bit different. Going to be a little bit more interesting, right? Because we can just do it off the top of our head, but we can still totally do this. Obviously, calculator takes forever to come up here. Let's get that out of here. All right, so little a means all values. So I'm going to write down all values. Okay, little a means all values, and it looks like my sign is negative. So where is sine negative? If we think about it, sine is negative in the third and the fourth quadrant. Okay, cool, fine. Well, we need to find one of those values. Now we're going to have to use our calculator, right? So the first thing you want to make sure is your mode. They said round to the nearest minute, right? So we're going to make sure we're in degrees, which I am, so that's good. Now, when you do the inverse sine of negative 0.452 in the calculator, it's only going to give you a principal value. So let's just jot down calc is principal value. Okay, which is great. It's fantastic. But you're going to have to find all the values. So just know that. Okay, so let's go to the calculator. We are going to do, there we go, inverse sine, negative 0.452. We're going to hit enter. Now, it does say round to the nearest minute, so we are going to smack it with the DMS. So negative 26 degrees, 52 minutes. So negative 26 degrees, 52 minutes. Now, what quadrant's that in? It's quadrant 4, right? So here's our quadrant 4 answer. We get quadrant 4 and quadrant 3 we're focusing on. Okay, so if we're in quadrant 4, we are going to add 360 degrees or subtract 360 degrees to get all the values, right? So we're going to add 360 degrees times however many rotations forwards or backwards you want. So you've got your quadrant 4 answer. This is done. But we got to find the quadrant 3 answer, and we're going to have to think a little bit about that. So let's think about what's happening here in quadrant 4. In quadrant 4, we went down 26 degrees and 52 minutes. So this reference angle is literally 26 degrees, 52 minutes. So let's remember how over here, like we had a reference angle of 30 and then we put the reference angle of 30 here and we calculated it, right? Same deal here. So this is a reference angle of 2652. So if we're looking at quadrant 3, and we have a reference angle of 26 degrees, 52 minutes, what is this angle right here? So you'd add 180 to it, right? So let me do this. Actually, clear that. Let's do this. And because I don't feel like retyping it, although, you know, it probably would have been quicker just to retype it than for me to do this. But you know what? Live your life. All right, so we've got this, but I don't want the negative. It definitely would have been quicker for me to just rewrite it. This is a little silly what I did here. Let's delete that out of there. Okay, so we've got our angle here, and I'm going to add 180 to it. Now, some of you could have added this in your head. Am I right? You could have added it in your head. So 260 degrees and 52 minutes. So right here, we have 206 degrees and 52 minutes, right, for my quadrant 3 answer. And then that's plus 360 degrees times however many rotations forwards or backwards you go, right? So there's your two answers. So a little bit trickier with the reference angle. Some people have issues with that. So just be careful right there. So let's do this one. This one's easy because remember, capital means principal value. And this is the exact same problem. I'm just showing you the difference. And doesn't the calculator give that to you automatically? The calculator does. Okay, so calculator knows principal value. So straight up, negative 26 degrees, 52 minutes would be your principal value. Okay, so there's a difference between those. Little arc, big arc. So let's talk about cosine. Cosine is the first one of these. So the first number, the first number, the first number. And at 0 degrees, we're at 1. At 90 degrees, we're at 0. At 180 degrees, we're at negative 1. At 270, we're at 0. And then we can keep going forever and ever, which gives you that graph, right? So that's all values. That's the whole graph, the whole shebang. This is like principal value, right? But the graph can go on forever and ever. So because of that, we have the same deal here. So let's do, this one's all values because it's little arc. So all values. And when is cosine? Okay, so cosine is positive, right? Root 2 over 2 is a positive. So cosine is positive in 1 and 4. Cosine is root 2 over 2 at, it says degrees, so we'll use degrees, 45 degrees. So in quadrant 1, this one's pretty easy, right? If I'm at 45 degrees in quadrant 1, then literally it's 45 degrees plus 360 times however many rotations forwards or backwards, right? And then in quadrant 4, we're going to put that same 45 degree. So this is 45 degrees, boom. And how many degrees is this? Now you can say negative 45 plus or minus, I'm sorry, plus 360K. If you want to do that, that's fine. I do not care. I'm just going to go with this. So 315 plus 360 degrees K. You can use negative 45. You can use negative 45. I don't care. It's fine. All right, so there's all the values. Well, what about the principal value? All right, so if we want the principal value, we know that inverse cosine operates here and here. A positive is here. So it's just going to be straight up 45 degrees. So just note the difference between the two. All right. Okay, calculator. So nearest minute. So why don't we do the principal one first, because we're going to use it in the other one, right? So this is a principal value. So I would go into the calculator and make sure your mode is on degrees. So I just want to reiterate that. And we're going to do second cosine negative 0.652. So second cosine negative 0.652. And I'm going to pop that in there. I'm going to DMS it. Okay, so we're going to round up. So 130 and then 42. So 130 degrees, 42 minutes. That is your principal value. Now you're going to use that for all values though, right? So we're going to come over here, arc cosine, so this is all values because it's little a. So when is cosine negative? 2 and 3. Well, 130 degrees is in that quadrant 2 already. So we already got our quadrant 2 answer. Our quadrant 2 answer is 130 degrees, 42 minutes plus 360 times however many rotations. Okay, but we need to find a quadrant 3 answer. So here's what I want you to think about. We need to know what our reference angle is, right? So if this right here is 130 degrees and 42 minutes, what is our reference angle? Okay, we have to find that because we need to know it for quadrant 3 to find out our new angle. So if I do 180 minus 130 and then 42 minutes, and then do this, 49.18. So our reference angle is 49.18. Now I'm going to pause here. I'm going to take back over in class. So just save it right here, and we will talk when we see each other again. Until next time, goodbye.